Hello, I'm Dr. Prem Kumar. Let us discuss about the linear hashing technique. It is one of the dynamic hashing technique. Linear hashing is an alternative of dynamic hashing technique. In dynamic hashing technique, you are having the concepts of extendable hashing and linear hashing. One is extendable hashing, the second is linear hashing. Already we discussed about the extendable hashing techniques. Now let us have a discussion on the linear hashing technique. There is a small difference between the extendable hashing and the linear hashing. In extendable hashing, whenever there is a overflow, there is a concept called overflow. Whenever there is a overflow, the bucket splits. Whereas in linear hashing, when there is a overflow, there is no hard and fast rule that bucket should get split. It depends upon the levels and rounds. We will discuss that with simple example. The purpose of linear hashing. It is used for faster fetching, searching the values. There are some thousands of values, lakhs of values. I want to search for a particular record. So without wasting time, immediately within no time, you can catch hold of that record with the linear hashing technique. Let us discuss an example on linear hashing. H0 is key mod 4, H1 is key mod 8, H2 is key mod 16, and H3 is key mod 32, and so on. If the bucket size is 4, we need to start the hash function from key mod 4, key mod 8, H1, H2, key mod 16, H3, key mod 32. Let us take some values. These are the values I am going to demonstrate. 32. I am using H0 hash function key mod 4. 32 mod 4 is 0. 0 in binary, least significant bits, 2 bits. You please consider 2 bits binary 0 0. So 32 is to be placed in 0 0 bucket. 32 is placed in 0 0 bucket. You can observe here hash function 0 H0. Initially I am taking 4 buckets and size of each bucket is 4 values. I am taking the next value is 9. Next value is 9. 9 mod 4 is 1. 1 in binary is 0 1. 2 bits, 2 bit representation. So this 9 is to be placed in 0 1. 9 is placed in 0 1. You can notice here 9 is in 0 1. 14 mod 4 is 2. In binary it is nothing but 1 0. 14 is to be placed in 1 0 bucket. 14 is placed in 1 0 bucket. You can notice here 14 is placed in 1 0 bucket. 31. Next we are taking 31. 31 mod 4 is 3. In binary, 3 in binary is 1 1. So 31 is to be placed in 1 1 bucket. 31 is placed in 1 1 bucket. The next is 44. 44. We are taking 44 in the series. 44. 44 mod 4 is 0. 0 in binary is 0 0. 2 bit representation. So 44 is to be placed in 0 0 bucket. 44 is placed in 0 0 bucket. The next is 36. 36. 36 mod 4 is 0. 0 in binary, 2 bit representation is 0 0. So 36 is to be placed in 0 0 bucket. 36 is placed in 0 0 bucket. Next is 25. 25 mod 4 is 1. 1 in binary is 0 1. So 25 is placed in 0 1 bucket. 25 is placed in 0 1 bucket. 5 mod 4 in our series, the next one is 5. 5 mod 4 is 1. 1 in binary is 0 1. So 5 is placed in 0 1 bucket. 5 is placed in 0 1 bucket. Next is 35. 35. 35 mod 4 is 3. 3 in binary is 1 1. 2 bit representation 1 1. So 35 is to be placed in 1 1 bucket. 35 is to be placed in 1 1 bucket 1 1. Now I am taking 18. In our series the next number is 18. 18 mod 4 is 2. 2 in binary is 1 0. So 18 is to be placed in 1 0 bucket. 18 is placed in 1 0 bucket. 1 0. 18 is placed in 1 0 bucket. The next is 7. 7 mod 4. 7 mod 4 is 3. 3 in binary is 1 1. 3 in binary is 1 1. So 7 is to be placed in 1 1 bucket. 7 is placed in 1 1 bucket. You can notice here I am placing 7 in 1 1 bucket. Next is 10. 10 mod 4 is 2. 2 in binary is 1 0. 2 bit representation. 2 in binary is 1 0. So 10 is to be placed in 1 0 bucket. 10 is placed in 1 0 bucket. 11. 11 mod 4 is 3. 3 in binary is 1 1. So 11 is to be placed in 1 1 bucket. 11 is placed in 1 1 bucket. Next I am taking 30. 30 mod 4. 30 mod 4 is 2. 2 in binary is 1 0. Least significant bits in 2 bit representation is 1 0. 30 is to be placed in 1 0 bucket. 30 is placed in 1 0 bucket. Now I am taking 43. 43 mod 4 is 3. 43 mod 4 is 3. 3 in binary is 1 1. So 43 is to be placed in 1 1 bucket. 43 is to be placed in 1 1 bucket, means it is to be placed here. But here you notice the point, the bucket size is 4. The bucket size is 4. All the 4 values are available here. You can't accommodate 43 in this bucket, and hence overflow occurs. Here there is an overflow. In fact, here you need to attach 43. So you are having an overflow. Here there is an overflow. You are getting an overflow here, 43. So whenever there is an overflow, you notice the point, there is a pointer in a blue color I am indicating. It is pointing out to the first bucket, that is a 0th bucket. So this bucket gets split. This bucket gets split. You get an extra bucket. Here, as the resultant of split, the 0 0, as it got split, you are getting here, you can notice here, previously you are having 1, 2, 3, 4 buckets. Now you are getting 5 buckets, 1, 2, 3, 4 and 5. 5 buckets. As a result of the split, you got one bucket extra. And these values are to be rehashed. The 32, 44 and 36, these values are to be rehashed and pointer is to be moved down. Now I am rehashing this 32, 44 and 36. 32 mod 8. So we need to rehash with the next hash function. We are working with the H0 function, that is mod 4. Now while rehashing, you need to rehash with H1 function, that is nothing but mod 8. Mod 8, you need to rehash with mod 8. Till now we are using H0 function, that is mod 4. Now I need to rehash with mod 8. That's what I am doing. 32 mod 8 is 0. 3 bit representation now 0 0 0. Now 32 is to be placed in 0 0 0 bucket. The next is 44. 44 mod 8 is 4. 4 in binary, 3 bit representation 1 0 0. So the 44 is to be placed in 1 0 0 bucket. 1 0 0 bucket. Here you can notice here 1 0 0 bucket. The next is 36. 36 mod 8 is 4. So 36, 4 in binary is 1 0 0. 3 bit representation. 3 bit representation. 36 is to be placed in 1 0 0 bucket. 36 is placed in 1 0 0 bucket. It is being placed here 1 0 0 bucket. You observe here, previously the next pointer is pointing out to the 0th bucket. Now it got pushed down. The next pointer got pushed down. From 0th bucket, the next came to the first bucket. It came to the first bucket, right? Now I want to insert 37. 37 mod 4. I am using H0 function. 37 mod 4 is nothing but 5. 5 in binary is 101. Least 2 significant bits are 01. 5 in binary is 101. The least 2 significant bits, LSB, the last 2 significant bits are nothing but 01. So 37 is to be placed in 01 bucket. 37 is placed in 01 bucket. You can notice here 37 is placed in 01 bucket. Now I am inserting 29. 29 mod 4 is 1. 1 means it is a 01. In binary, it is 2 bit representation of 1 is 01. So 29 is to be placed in 01 bucket. 01 bucket. So here already there are 4 values here. The bucket size is full and hence there is an overflow. The 29, it is an overflow. Remember, whenever there is an overflow, the bucket with the next pointer gets split. The bucket with the next pointer gets split, right? And the values are to be rehashed with the next hash function. Means present we are using h0, it becomes h1 function. And then the pointer is to be moved down, pushed down. That's what I'm doing. You can observe the next slide. In the next slide, what I'm doing is all the values here, the 0, 1 are rehashed. Here 9 mod 8, you notice here I'm saying mod 8, 9 mod 8 is 1, 3-bit representation is 001. So 9 is to be placed in 001, 001, 9 is placed in 001. Next is 25, 25 mod 8 is 1, 3-bit representation it is 001. So 25 is to be placed in 001, 25 is placed in 001. The next value is 5, previously here there is a 5, previously here there is a 5. 5 mod 8 is 5, 3-bit representation is 101, 101. So you place it in 101, the 5 is placed in 101. The next, previously here you are having 37, previously here there is 37, 37 mod 8 is 5. 5 in binary, 3-bit representation is 101. So 37 you place it in 101. So 37 is placed in 101 bucket. Next is 29. You are having overflow. Previously here there is a overflow. 29 mod 8 is 5. So 5 in binary, 3-bit representation is 101. So 29 is to be placed in 101 bucket. 101 bucket. So this is, now you don't have that overflow bucket. After that, the next pointer is to be pushed down. The next pointer is to be pushed down. So previously here there is a next pointer, it is coming down. The next pointer is coming down. Now you observe here, now I want to insert 22. Now the 22 mod 4, I am using h0 function, 22 mod 2, 22 mod 4 is 2. 2 in binary is nothing but 0, 1, 0. So I need to place in 1, 0 bucket. This 22 is to be placed in 1, 0, 1, 0, here 1, 0, here hang 1, 0. But here 1, 0 bucket, already it is having 4 values and hence there is an overflow. Whenever there is an overflow, the bucket with the next pointer gets split. When I rehash the values, the bucket came down and the previous values I am rehashing. The previously here there is a 14, 14 mod 8 is a 6, 6 in binary is 110. So 14 is to be placed in 110 bucket. 14 is placed in 110 bucket. 110 bucket. You got 14. And previously here you are having 18. 18 mod 8 is 2. 2 in binary 3-bit representation is 010. 18 is to be placed in 010 bucket. 18 is placed in 010 bucket. Next is 10. You are having 10. So 10 mod 8. 10 mod 8 is 2. 2 in binary 3-bit representation is 010. So 10 is placed in 010 bucket. 10 is placed in 010 bucket. The next 30. Previously here you are having 30. The 30 mod 8 is 6. 6 in binary 3-bit representation is 110. So place 30 in 110. 110. Place 30 in 110. 110 bucket. Right? Now I am taking 22. The 22 mod 8 is 6. The 6 in binary 3-bit representation is 110. 22 is to be placed in 110. 22 is placed in 110 bucket. So we rehash and the next pointer is pushed down. So you got the next pointer came down here. Here you got the next pointer. Okay. Now I would like to insert 66. The number to insert is 66. So when I am trying to insert 66, I am using hash function h0. So 66 mod 4 is 2. 2 in binary is 10. 2 in binary is nothing but 10. So you place the 66 in 10 bucket. 66, you are placing 66 in 10 bucket. You are placing 66 in 10 bucket. I would like to insert the value 34. 34 mod 4 h0 function. 34 mod 4 is 2. 2 in binary is nothing but 10. You need to place 34 in 10 bucket. 34 is placed in 10 bucket. 34 is placed in 10 bucket. Okay. Now I am taking 50. 50 mod 4 H0 function is 2. 2 in binary is 10. So 50 is to be placed in 10 bucket. 50 is to be placed in 10 bucket. But 10 bucket is already filled up with 4 values. The bucket size is full and hence there is a overflow. Remember, whenever there is a overflow, the bucket with the next pointer, gets split. And hence, previously here hang 6 buckets. Now you got 7 buckets. Now you are getting one extra bucket down. You can see here the value 31 mod 8 is 7. It is placed in 111 bucket. 31 is placed in 111 bucket. 31 is placed in 111 bucket. 35 mod 8 is 3. So 3-bit representation is nothing but 011. 35 is placed in 011 bucket. 35 is placed in 011 bucket. Next is 7. 7 mod 8. 7 mod 8 is 7. 7 in binary is a 111. Least 3 significant bits is 111. 7 is to be placed in 111 bucket. 7 is placed in 111 bucket. Next is 11. 11 mod 8 is 3. Its binary representation is 011. 11 is placed in 011 bucket. 11 is placed in 011 bucket. 011 bucket. 11 is placed in 011 bucket. And of course there is a overflow here 43. For this bucket there is a overflow 43. So 43 mod 8 is 3. 3 in binary is 011. So 43 is placed in 011 bucket. 43 is placed in 011 bucket. 43 is placed in 011 bucket. 011 bucket. 43 is placed in 011 bucket. 43 is placed in 011 bucket. Right? So this is how we are rehashing the values. Linear hashing technique. This is a linear hashing technique. It is used for faster searching. For example, I want to search some value like 25. First you say 25 mod 4. 25 mod 4. The remainder is 1. You try to look into 1. 1 in binary is nothing but 01. You try to look into the 01 bucket. 01 bucket. 01 bucket. 25 is available. We require value 25. It is directly available in 01 bucket. Right? Suppose I want to search for some value 43. 43 mod 4 is nothing but 3. You search in 3 in binary is nothing but it is 11. 2-bit representation is 11. So 43 should be available in 11 bucket. That is 3. 11 bucket. In 11 bucket 43 is available. Directly you can search. There may be lakhs of values, but your searching speed gets increased tremendously, which is the benefit of this linear hashing technique. With the linear hashing technique. It is one of the dynamic hashing technique. In dynamic hashing technique, the database grows. So whenever a new value comes, the previous values which are stored in the memory, they get adjusted. That is the advantage of dynamic hashing technique. And of course, we already discussed about the static hashing technique. In static hashing technique, whenever a value is placed, the value resides in the same position. But in dynamic hashing technique, whenever a new value comes, the old values will be adjusted depending upon the new value. So dynamically the positions of the existing values gets changed. That is the advantage of the dynamic hashing technique. Low overheads and splitting and merging. So number of times we will split the buckets and we will be merging the buckets. So while splitting and merging, whenever you delete, you will be merging. So the splitting and merging is a hectic process where in this linear hashing technique, the overheads are less. Efficient handling of overflow. So while overflow occurs, the buckets need to be splitted and the performance may get degraded in the different other hashing techniques, dynamic hashing techniques, whereas the performance is perfectly maintained. With a greater performance, the overflow, whenever the overflow bucket occurs, the splitting takes with a great speed. So here there is a time complexity is being maintained. This linear hashing focuses both on the time complexity and space complexity. Better scalability, that is support for incremental growth. Even if I put some lakhs of values, the dynamic hashing, that is the linear hashing technique, will accept the values and adjust those values accordingly. So there is a better scalability. You can increase the values or you can even decrease the values. The scalability is very high. Reduced fragmentation, it is a space complexity concept. Reduced fragmentation, more fragmentations leads to wastage of memory, whereas here you are having the reduced fragmentation. So less fragmentation, less wastage of memory. So even the memory management can be done effectively, efficiently. Ease of implementation. So implementation is easy. The algorithmic implementation. The algorithmic implementation is comfortable when compared with the other hashing techniques. And performance in real-time environment. When the workload is more, when the workload is unpredictable, when the data is frequently occurring, so in real-time situations you can do well with this linear hashing technique. There are different techniques and some are experimentally proved and that is fit for experiments. But for real-time applications, when you go with the real-time applications, this is the best technique. That is the linear hashing technique. Balanced query performance. The linear hashing aims to evenly distribute data on the buckets. So distribution data will not be skewed. So the distribution of data is even in every bucket. So evenness will be maintained so that the searching process becomes easy.